Welcome to my YouTube channel. Dhanesh here. So this is the third video on gradient descent. So we were discussing with gradient descent. So before getting into the details of gradient descent, I want you to revise some of the aspects. In the previous videos, we covered calculus, maxima, minima, partial derivatives. How do we find out the minima of a function by using calculus method? All those aspects we covered. See slope. See, for example, here you can see this is a line. This is our machine learning model. This line is represented by y is equal to mx plus c. See, if you see this angle, so this angle theta, so we are taking it as theta. See, the tangent of this angle, we call it as the slope. So what is slope? Tangent, it's a trigonometric function, sine, cos, tan. So I told this angle, this is the angle made by the line with the positive direction of the x-axis. The tangent of that angle, we call it as the slope. Slope is given by another equation. It is, slope, it is tan theta. One equation is tan theta, tan of this angle we already covered. It is slope is tan theta, or y by x, that's also slope. Or we can, in differential form, in terms of calculus, we can call it as dy by dx. In the previous videos, even we covered partial derivatives as well. See, all those aspects we covered. So again, we are coming back to the gradient descent algorithm. So what is gradient descent? We already discussed. So gradient descent, it is an iterative optimization algorithm. It is an iterative, repetitive process. So gradient descent is an iterative optimization algorithm for finding the minimum of a cost function. That's what we discussed in the previous videos. So what is gradient descent? It's an iterative optimization algorithm for finding the minimum of a cost function. So cost function denotes error. We discussed previously. Cost function always represents error. So for a machine learning model, error must be minimum. So to minimize this error, we are using this gradient descent algorithm. So here you can see error is equal to predicted value minus actual value. See, predicted value minus actual value, in the sense the predicted value represents the, see, in this model, if you see this straight line, the points in this straight line, this it's a linear regression model. So the points in this straight line represents the predicted values. So when we use this predicted model, this machine learning model to with the testing data, so we will get error. See, this is the error. So this is the machine learning model. So here, when we use it with the testing data, this is the actual value. The dot represents the actual value, and here in this model, this is the predicted value. That difference we call it as error. So error is equal to, that is represented by the cost function, predicted value minus actual value. Here in this equation, sigma represents the summation, I is equal to 1 to n. We are taking error square. See, why this mean square? 1 by n represents the mean, and square. Why we are using this square and then we take the mean? The reason is, when we see these points, when we calculate the predicted value minus actual value, See, sum of the points for this, the predicted value for this result, the predicted value minus actual value is negative. When we come to this point, the predicted value minus actual value is positive. Here it is positive because here the predicted value is higher than the actual value. Here it is negative. The reason is here the actual value is higher than the predicted value. So for example, if you take this is the predicted value and here this is the actual value. Let us assume that the y-axis represents height. We are predicting we are using this model to predict the height. X-axis represents the weight. See, for a particular weight, what should be the height? So in that case, this is the testing data, this is the actual value. Our model predicts this much height. So the actual value is higher than the predicted value. Here it is negative. When we calculate the error, it's negative. Here it is positive. See, when you add this positive values and negative values, finally when you add positive negative, you can get 0 or some other result that won't be proper, that won't be correct, because the positive values and negative values will cancel each other and you won't get the exact error. So that's why when you square it, even the negative values becomes positive. The square of a negative number is positive. The square of a positive number is also positive. So in that way, when you square it, you will get the exact error. Otherwise, the positive and negative will be cancelled. So that's why when you define a cost function, you will square the error and you will take the mean. So that's the importance of mean square values in statistics and machine learning. That's why we define it. Even if you are familiar with, if you know about, more about physics, there, when you discuss about the gaseous molecules, there also their velocity, we define it as root mean square velocity, RMS velocity. So another approach is, first you take the square, then mean, then root. So when you get positive and negative values in your data, so what is the approach to get the proper result? One approach is mean square, another one is RMS, root mean square. Anyway, so you understood why we are squaring the error, because the predicted value minus actual value can be positive and negative. So when you square it, you will, all the results will be positive and you will get the exact result. So this is the that's why we square it. So you understood that. Now see here, error is predicted minus actual. So predicted value means, see in this graph the line represents the predicted value. So that's why it is y dash, and y means the actual value, the testing data, what it represents, that is y dash minus y represents the predicted value minus actual value. But the predicted value of y dash is the line, the equation of a line is mx plus c. So I substituted y dash as mx plus c minus y the whole square. So 1 by n is for taking the mean. 1 by n sigma I is equal to 1 to n. Y dash is the predicted value, that is this line, the machine learning model. So it is mx plus c minus y the whole square. This is the perfect equation for cost function or error function or loss function or objective function. So 1 by n sigma I is equal to 1 to n mx plus c minus y the whole square. So that these are all the things you need to know about the cost function. So next time we're going to discuss another term we use here. It is back propagation. What is back propagation? So we will discuss about that. See, back propagation aims to minimize the cost function by adjusting networks weights and biases. See, here I have written here. So back propagation is a process to minimize the cost function by adjusting networks weight and bias. See, what is weight and bias? It's not that much complex terms. It's simple. We already covered in the previous videos as well. See, in the machine learning model, see, it's a linear regression line, whatever we are discussing. Here y is equal to mx plus z, and here m is the slope and c is the y-intercept. I already told you, m is the slope and c is the y-intercept. See, y-intercept means, you can understand here, if I am drawing a line like this, you can see here. See here, for this line, the y-intercept is 0. Whatever line I have written, the y-intercept is 0. If I am drawing a line like this, then the y-intercept is the distance. This distance, we call it as the y-intercept. This is the y-intercept. You can see it here. So this distance from here to origin, from this point to origin, this distance we call it as the y-intercept. See, you are clear? Now you need to understand, see, the slope m we call it as the weight of the network, and the y-intercept c we call it as the bias. That's all. So back propagation is the process. It aims to minimize the cost function by adjusting weight and bias. What is weight? In simple terms, weight is the slope. And what is bias? Bias is the y-intercept. That is the easiest way of understanding weight and bias. See, in neural networks, we discuss about activation function, weight and bias. So you can more ideas in terms of neural networks. We need to get into more details, but here we are our discussion is limited to gradient descent algorithm. So for the time being, this you need to understand, m is the weight and c the y-intercept is the bias, and y-intercept means this distance. For this first line, the machine learning model, our first line, the y-intercept is 0. To understand the y-intercept, I have drawn one more line this. For that, the distance, this distance, we call it as the y-intercept. Now, another term we need to understand here to understand about the gradient descent is learning rate. See, what exactly is learning rate? So this learning rate is a term we define in statistics and data science. So it is actually, it came from statistics only. Learning rate, it's originated from statistics, and it is denoted by the letter alpha. So in machine learning and statistics, learning rate is a tuning parameter. It is a tuning parameter in gradient descent or in any optimization algorithm. In all optimization algorithms, see, in gradient descent we are using, we are trying to optimize the weight and the bias to get the minimum cost function. So in any optimization algorithm, we use this learning rate. So even here, gradient descent is an optimization algorithm and we are using it, and it determines, this learning rate determines the step size. Very important. It determines the step size. This tuning parameter determines the step size at each iteration while we moving forward the minimum of a cost function. So it determines this learning rate. This tuning parameter determines the step size while moving towards the minimum of a cost function. So that is learning rate, and it is denoted by the letter alpha. So this step size, how many baby steps we take to reach the minimum of the cost function. That baby steps, the size of the baby steps, we call it as the learning rate. When we so in machine learning and statistics, the learning rate is a tuning parameter using in an optimization algorithm that determines the step size. It determines the step size at each iteration while we are moving towards the minimum of a cost function, and it is denoted by the letter alpha, and its minimum value is 0 and its maximum value is 1. Its minimum value is 0 and it varies from 0 to 1. And if alpha is very low, then we need to understand the training of the machine learning model is it progresses very slowly. That's what, if alpha is very low, for example if it is 0.01 or 001, then 0.001, what does it mean is the training of the machine learning model progress very very slowly. If alpha is very high, then it can cause undesirable behavior in the cost function. We cannot minimize the cost function if you are putting alphas very high. So when we do the Python program, and when we get into the details of this gradient descent in the coming videos, you will be getting how we will change the learning rate to optimize this cost function, to minimize this cost function. See how that you will understand. So that's what, if alpha is very high, it will cause the undesirable outputs in the cost function. If it is very if it is very low, then the meaning is like the training is very slow. So the alpha we need to select in between. That's by repetitive process, by different iterations we need to understand what value we can choose for this learning rate. So that's all about in this video. So in the next videos we will be getting into the complete details of the gradient descent algorithm, how we are going to implement it in Python. So all these aspects we will be covering in the next videos. So thanks for watching.